dear students, once again welcome to this physics YouTube channel. So in previous class we have discussed about the law of conservation of momentum. Okay, so momentum neither be created nor destroyed. The total momentum of the system before and after collisions are same. Okay, and also all of you know, according to the Newton's second law, the force impressed on a body is directly proportional to the rate of change of momentum, and already all of you know the force is equal to mass into acceleration, F equal to ma. Cleared? Okay, so now today we are to discuss equilibrium of a particle. See, a particle is said to be equilibrium, so it means no motion under the influence of force. Okay, so for equilibrium, or if you want to make the body is in equilibrium, you required two forces. So the minimum two force that will act on a body to make the particle is at rest. Okay, suppose F1 and F2 are the two forces which are acting on a body. So under the action of these two forces, if the body does not move in any one of the direction, so then we can say it is equilibrium. Here two forces F1 and F2 are acting on a body, or so it is equilibrium means no motion. Okay, so clearly the net force on that body is 0. The body is equilibrium only when its net force on it is 0. So it is possible only when two forces having equal magnitude and opposite direction which are acts on a body, so then the body becomes equilibrium. So in first figure gives the two forces, okay, which are acting at a point in opposite directions. So then if the body is equilibrium under the action of two forces F1 and F2, then clearly we can say the magnitude of F1 equal to magnitude of F2, and also the direction is opposite to each other. So you can say F2 is opposite to F1 or F1 is opposite to F2. Okay, so then only the body is in equilibrium. Okay, so this is the case. So it means the body is equilibrium under the action of minimum two force, remember. So now in the next figure there are three forces that will act on a body. Okay, see, suppose F1 and F2 are the two forces, so that will act on a body or acts at a point O. Okay, so it means these two forces are start with the same point, hence here we can say two forces are the two vectors, and the vector is, see, two forces F1 and F2 are acts at a single point, and their resultant gives along the diagonal. See, in this figure F1 and F2 are acting and you have to make two more lines which are parallel to F1 and F2, and the diagonal gives the resultant. Okay, so now the body is not in equilibrium under the action of two forces F1 and F2, remember, because the directions of F1 and F2 are not in opposite direction, and even maybe unit is also not equal, means the magnitude of the force is not same. Okay, so here the dotted line, the diagonal in the second figure, the diagonal gives the magnitude and direction of these two forces, that is F1 plus F2. So to make the point or the body is in equilibrium, means you have to add one more force to make the body is in equilibrium. That third force must be equal to the vector sum of these two forces, that is vector sum of vector F1 plus vector F2 and its opposite direction, because the diagonal gives the vector F1 plus F2. So you have to extend the diagonal in opposite direction. So that diagonal having the same length gives the magnitude and direction of the resultant of two vectors. Okay, so now we can say equilibrium under the concurrent forces. Concurrent means their starting point is same, concurrent or co-initial vectors, so like that. So now the diagonal gives the sum of vector F1 and F2. So you have to make the body is in equilibrium, means you have to make the net force on the body is 0. So already two forces which are acts on a body and their magnitude and directions are also shown in the figure. So third force must be equal to the resultant of F1 and F2 and the direction is exactly opposite. Now by considering these three forces, that is F1, F2 and F3 are acts at the same point. So and the length of the F3 is the magnitude of the force, and the magnitude of the force F3 is same as the length of the diagonal. So length of the diagonal is the resultant of F1 and F2. Now under the action of three forces F1 and F2, F1, F2 and F3. Okay, so now the body is in equilibrium because the net force on that body is 0. Cleared? So hence generally we can say if the number of forces which are acts on a body, then their vector sum equal to 0. 0 is vector sum. Cleared? Okay. Note down these points. So let us to discuss the common forces in mechanics. Common forces in mechanics. So in mechanics, gravitational force is the most force exerted by the earth on all unsupported bodies. Okay, next one is the tension. Tension is also force, remember. When a load is suspended from a string whose other end is fixed to a support, restoring forces are set up in the string due to property of elasticity. Point. This restoring force in a string is called the tension. So simply remember, tension means it is the force. So that force that will be restored in that body, and that force itself is called as the tension. Okay. So next one is spring force. See, this spring force, or simply spring, means it is the device used to restore the force. So as if you move the one end as distance x, and the force exerted by that massive object is also same, but what happens, the direction. So hence there is a one simple method you have to adopt, that is spring force. See, if one end is fixed, one end is moved, means the body, one end of the spring is get compressed, so that its length will be changes as delta x. So therefore f equal to minus kx. Okay, x is proportional to k. Okay, but where f is spring force, second one is displacement, and third one c, f equal to minus kx. X is the displacement, k is the spring constant, f is spring force. So it has many applications also. F equal to minus kx. Okay, so we can measure with the help of spring. With the help of spring, we can measure weight of the body, that is spring balance. Okay, next one is the contact forces. Contact forces are those commonly encountered forces in mechanics. They arise due to the contact between a given body with some other bodies. Clear? So note down these important points we have already discussed. One is in that common force, tension. Okay, so just we have discussed some important and common forces in mechanics. One is okay, so gravitational force, tension, and spring force. Okay, then contact force. So these are the very common forces in mechanics, and in next class we can discuss the remaining part of it. So you have to write all the notes up to common forces in mechanics with explanation. Okay, so what may be the things in that is common forces in mechanics, everything is there in your notes. Okay, so try to collect these, and we can discuss in the next class. Okay, thank you.